of the experiments. I'm going to go for step 1, and I will also talk while I'm doing the experiment, so it would give you a little bit more information. For step 1, we have to prepare sodium hydroxide solution. So to prepare the sodium hydroxide solution, we're going to take the 50 milliliter of the 3 molar sodium hydroxide. When you buy your lab manual, you will read the procedure, you will follow the procedure. So some of the numbers, you find it there. I don't have to write exactly for you, but anything that you cannot, any number you cannot find it in the lab manual, I'm going to write it for you, so you could have the numbers for your data sheet. We are making 600 milliliters of sodium hydroxide solution, and the standard that we are using is a 3 molar. We are going to read from experiment 1 that measurement with graduate cylinder is not the most accurate measurement. So I'm using the graduate cylinder, but I'm going to standardize the solution later. So the calculation that is used now based on the dilution is not the most accurate. It's not going to give me the most accurate number, but after I standardize, I'm going to give you the exact number for you to calculate molarity for the base. And when you have the molarity for the base, then you have a standard to use for rest of the experiment. Okay, after you mix the concentrated and dilute solution, you have to mix it very well, because solution must be uniform. So we don't want high concentration of sodium hydroxide at the bottom and low concentration on top. So it has to be completely mixed. Next step, I'm going to take the Erlenmeyer flask, measure the mass of the flask, measure the mass for empty flask, because I want to make sure that is going to match with what you have in the data sheet. So for the data sheet, you are going to use, for part 1, you need the mass of empty Erlenmeyer flask. It's going to be 119.632 gram. This is the mass for empty flask. Then we add about 1.2 grams. That would be 120.8, about 120.887. This is going to be the mass of flask plus and KHP for trial 1. We are going to add 50 milliliters of dry water. This was used for sodium hydroxide. It's a clean one. Milliliter of the dry water just to dissolve the sample, and let it stand until it's completely dissolved before we can use it. So we also add 3 to 4 drops of the acid-base indicator. The acid-base indicator of phenolphthalein is colorless in acidic solution. You see it's colorless. When we add the base at the neutral point, it will change to a light pink color. But if you add too much of it, it can go to dark pink or purple color, which it's not desired. Then, after we have the flask ready, now we want to fill up the burette with the sodium hydroxide solution. Now, next we have the initial burette reading. I have 1.00 initial burette reading. Trial 1. When I start the titration, I'm adding the base from the burette to the acid that I had in the flask until the pink color is stable for 20 seconds. You see the pink color appears in the center, but it disappears after I mix it because the entire solution is not neutralized yet. At the beginning, I can add the base fast. See that I'm just pouring it, but after the life of this pink color gets longer, basically I'm getting closer to the endpoint of the reaction. And when I get close to the endpoint of the reaction now, I have to slow down and add 1 drop at the time. So if you see there is a white paper underneath, it's just to show me the color. Okay, so I have a light pink color. The color change is a light pink color. If this stays for like 20 seconds, that means I have added enough of the base. If it doesn't, then I have to add another drop. Final burette reading is 25.20. Trial 1. The volume of sodium hydroxide is going to be final minus initial, which you have to do the calculation. And then the molarity of sodium hydroxide, you need to do the calculation for the molarity of sodium hydroxide. I only give you the numbers, and you are going to read the introduction part of the experiment in order to perform the calculation. So basically, you find the number of moles, you find the mass for KHP, you find the moles for KHP, and then you say number of moles of KHP equals moles of sodium hydroxide. And then from moles of sodium hydroxide, then you have moles of sodium hydroxide, you have the volume for sodium hydroxide, you can calculate molarity for sodium hydroxide. So I do explanation, but hopefully you're going to rewind that a couple times, read it and listen to it, make sure that you understand what to do with the calculation. Okay, I'm going to refill the burette with sodium hydroxide because I don't want to use entire sample, and if I go below 50, there is no line there and I cannot basically read the numbers below 50. There is no graduation line. Second trial, 8.00 is initial burette reading. Mass for the flask, 116.255. 116.255. KHP, 1.2 grams, about 1.2 grams. So 117.3 is going to be sufficient. So mass of flask and KHP for trial 2 is 117.521. 117.521. You're adding the 50 milliliter water. I kind of pour it around the flask to make sure any powder, if it's on the wall, it can go down. Add 3 drops of phenolphthalein. Try to dissolve it. The first time we added about 20 milliliters, right? At least 24 milliliters, that's what we added. I have slightly more KHP, so I should be able to confidently add 24 milliliter or 25 milliliter and then low down. So the second trial, I have better idea how much of the base is going to be used. So if I start from 8 and I go to 28, that would be 20. I can even go to 30 because I'm using 22 milliliters or more. Actually, we should look at the color change and not worry about the numbers up here. But when the color change happens, then we look at the burette, we record the number. Light pink color change, which happened with one drop, addition of one last drop. After the 20, almost 24 milliliters. So I'm recording this number as 32.123.5. 32.35. 32.35 is the final burette reading. Okay, the two numbers, they are in close agreement. I don't have to do trial 3 because trial 3 is like if you need it, which I don't have to use it. I'm not going to use the trial 3 at this point. So we are done with part 1 of experiment 6. I'm going to move to part 2 of the experiment 6. I need to wash my flask. I need to refill the burette. My sodium hydroxide is ready, but I need to refill the burette for sodium hydroxide. I'm going to add more sodium hydroxide. 10 milliliter of this stock solution. Now I have my stock solution of HCl because I'm using for different trials. Going to pipette 10 milliliters. With the pipette, the number on the pipette, it shows that if I fill up this pipette up to the index line, is going to have 10 milliliters of the solution. So this is a 10 milliliter pipette. The number shows 10. So if I fill it up to this index line, again, I'm looking for the meniscus, and that's what we are looking for now. So I'm going to fill up. This is the first time that I'm using this pump because you do have like those fancier ones. Just couldn't find it. So, and we are going to add 2 drops of the phenolphthalein. When you're dealing with human error, it doesn't matter if it's you or me or anyone. We could always have the human error. So looks like that a drop of it went outside of that flask, and I wasn't happy with it. So I said I'm going to make a new sample that I'm 100% sure is working. So the volume here is exactly 10 milliliters. So now, what information do you need for part 2 to record in order to finish your sample? For now, it's just initial burette reading. Part 2, trial 1, initial burette reading is 0.00. We're going to add enough of the sodium hydroxide until, same thing like the last titration, the pink color appears, disappears, but at one point it's going to stay or be stabilized for 20 seconds. That's what we are looking for. Why is necessary to add some water to wash the walls? Because sometimes the acid is on the wall, inside wall, and it's not being titrated. So you want to make sure that everything is mixed. If there's any acid on the wall, it needs to be washed out. Adding one more drop because it's very close to it. Okay. So just adding one drop, the pink color appeared. Now I have a light pink color of the solution. And that's the end point for the reaction. I stop adding sodium hydroxide. Read the volume is 24.45, 22.45, 22.45 is final ureth reading. Part 2, trial 1. One trial, it's never enough for titration. You have to have at least 2 trials. If the numbers are within the agreement, like 5% difference, then you can stop. Otherwise, you have to continue for the 3rd trial. So I have to do my 2nd trial now. I'm just washing one more time the flask. I already washed it. I was just rinsing with the deionized water to make sure there is nothing left over from prior experiments. I measure 10 milliliter of the acid. Exactly 10 milliliter has to be. Transfer. Transfer 10 milliliters of the acid. Add 2 drops of phenolphthalein. White sheet of paper. Washing down the acid to make sure that everything is down inside in the flask. I may not have enough. I might have or may not have enough of the acid. So I'm going to start with 23. Hopefully we have enough to finish the trial. So last time we used 22. If everything is the same as before, if I didn't make any mistake, I should also use another 22 milliliters or 22.5 or 22.45 milliliters. So I can confidently add fast to get to the 22 milliliters. I'm starting with 23. So it can go to 45. If everything is the same, if it works, see that pink color appears, and when I mix it, it disappears. It's not end point of the reaction. End point of the reaction would be when the color is maintained for 20 seconds. Has to stay for 20 seconds. If it doesn't stay for 20 seconds, we add another drop. So initial reading, this was for part 2. Now part 2, trial 2, initial ureth reading is 23.00. Part 2, trial 2, final ureth reading. Final ureth reading is 45.30. So with the 2 trials being closed, I don't have to do the 3rd trial because 3rd trial is not needed because the 2 trials, they were very close. Luckily, I was able to, remember to add phenolphthalein. Sometimes you don't remember to add phenolphthalein. You go like 10 milliliter higher than what you used for trial 1, and you don't see color change. Then you remember you didn't add the phenolphthalein, but this one, it worked out. So far, it's so good. So we are done with part 2 of the experiment. You are responsible for calculation, though. You have to do the calculation. Volume for acid each time was 10 milliliter. So you find the molarity for the acid. Number of moles of HCl, it comes from part 2. Number of moles of NaOH is the molarity times volume in liter for NaOH that was used. Anytime you are using the solution, molarity, that we have the molarity, it would be molarity times volume in liter, that gives you the number of moles for any acid or for any base or in general any solution. So